Okay, welcome to Math 9. Hope you had a good long weekend. We are headed into the very last section of Chapter 7. So we're going to finish up that section. We're going to finish up this section today. And then tomorrow, if you don't send me any questions, I'm going to review what we've done, which is just all the shapes. And then I think we'll do a test on, let's make it a test on Friday. That'll end your week great, won't it? Unless that conflicts with a bunch of other stuff. If it does, you can let me know. But we're going to do a test on Chapter 7 on Friday. So we'll finish up this section today. I'll answer any questions tomorrow, do a review. And then give you a day or so to study. And then we'll do what we normally do at 8:30 in the morning. I'll upload the test. You will have until 9:40 or so to finish it and get it to me, okay? So that gives you like your regular period time in order to finish it. Be sure that you're there. Be sure that you are doing it during that time frame. Don't sleep in that morning, okay? So, this section is on cylinders and cones. So a cylinder is just what you think a cylinder is. So I brought a jar of peanut butter to be a cylinder. So if we're doing surface area of a cylinder, remember surface area is just the area of all of it, like the area of the outside of all of it. So surface area for a cylinder. I can't spell, sorry, cylinder. Surface area for a cylinder. So let's look at what shape the top and the bottom are. So there's the top and there's the bottom. They are circles. So we know that the area of a circle is pi r squared, or I hope you know that because that's in the first section. So for surface area of a cylinder, pi r squared has to be in there. But we don't just have one circle, we have two circles, the top and the bottom. So we're going to multiply it by 2 because those two circles in a cylinder, if it's a true cylinder, should be the same. Now the complicated part is these sides here, this side. But it's not as complicated as you think. So I've already done some damage to this label. And I didn't manage to cut it straight up the side, but if I had, it's stuck, hold on. The label, if I take it off, actually is just one long rectangle, right? So it's a rectangle wrapped around the cylinder, that's all it is. So we know that the area of a rectangle is length times height. So the height's easy. It's just up and down, right? That's the easy part. Height is just the height up and down. But the length of this is actually the distance around the cylinder because the rectangle has to wrap around the cylinder. So the length of the rectangle, how far it is across when you unwrap it, is the same as the distance around the circle. In math, that's called the circumference of the circle. So if I'm going to do length times width, we know that the width is just the height, but the length is the circumference of the circle. So what is the formula for the circumference of a circle? And that is just 2 pi r. You probably learned that way back, I don't know, somewhere beginning in grade 6, grade 7, somewhere in there you learned about what is the circumference or the distance around the edge of a circle. So that is like your length, okay? Because the length of the rectangle is the circumference of the circle. And the width is just how tall is the cylinder. We now have the formula for surface area of a cylinder. It is 2 pi r squared plus 2 pi r h. We just have it. And again, area of a circle, and there are two of them, and then the rectangle, that's the length, that's the width. That's all there is to it. Now, volume for a cylinder, remember that we said the area of, or the volume, sorry, of any 3D object is the area of the base times how tall it is. So the base in this case is a circle, which is pi r squared times how tall it is, so times the height. So that's the formula for volume of a cylinder. Pretty straightforward. Then we have to do, well, I'll do an example. I'll do the examples with that first, okay? I'll do the examples, so we'll look at the cylinder first. So in example 1, it says you have a cylindrical can of juice. It has a diameter of 6 centimeters. So diameter means all the way across. And it has a height of 13 centimeters. And what it wants us to find is it wants us to find the surface area to the nearest tenth. Now I thought I brought Harriet up. Maybe I didn't. Okay, so if I'm going to find the surface area to the nearest tenth, that is 2 times pi times r squared. But they gave us the diameter, which is all the way across. So the radius is actually 3. Really watch for that. Did they give you the radius or did they give you the diameter? So we're not going to do 6 squared. We're going to do 3 squared plus 2 times pi times r, which is 3, not 6, times the height, which is 13. Now it's very important that you do order of operations. Don't do 2 times pi times 3 and then square it, because the only thing that is squared is that 3. So this is really 2 times pi times 9 plus 2 times pi times 3 times 13. Now you wouldn't have to, you could do this all in one step. I'm doing it in several steps so that you can see what I did. So this is 18 pi plus 3 times 13 is 39, and 39 times 2 would be 78 pi. And I would just put that in my calculator, and I would get 301.4 centimeters squared. All right. And again, they said to the nearest tenth. One of the things I've noticed in your work is you don't pay attention to what it says to round off to. If it says round to the nearest tenth, then you need to round to the nearest tenth, not the hundredth, not the thousandth, to the nearest tenth. You need to follow the directions. I will, on a test, take off points if you round to the wrong place or you round incorrectly. All right? And again, for pi, please use the pi button on your calculator. Do not use 3.14. That's not accurate enough. All right, so that's example 1. Example 2. And again, I'm in section 7.5. Example 2 says find the volume of the can of tennis balls. If you've ever bought tennis balls, they come in a can. And for this one, it says the radius is 3.75. So this time they give us a radius and not a diameter. That's good. And the height is 20.3. Now they say to this one to round to the nearest cubic centimeter, which means we're not going to have any decimal places. So we're looking for volume this time, which is pi r squared times h. So pi times 3.75 squared times height. Again, very important that you follow order of operations here. 3.75 squared, then times pi times 20.3. and it turns out to be 896.4, but they want it rounded to the nearest cubic centimeters. So because that's a 4, this remains a 6. So sorry, it's not squared, it's cubed, because we did centimeters squared times centimeters, which is 3. All right, so that's the cylinder. The cone is exactly what you think of. It's a cone. It's like an ice cream cone. The only thing to remember when you're talking about a cone is when they talk about a cone, the base is always the round circle. So basically, if you put ice cream in an ice cream cone, that's an upside down cone, because a cone, technically, the base is the circular part, and then it goes to a peak. All right, so we need to talk a little bit about the difference between height and slant height, because in surface area, you're going to use one of those terms, and in volume, you're going to use the other term. So slant height talks about the height from the edge of the cone up to the peak along this angled edge. It is slanted, so it is called the slant height. The height of the cone is actually from the center of the circle straight up to the peak. That is just plain old height. So the slanted side is the slant height. And that's important because, where's my eraser? There it is. Because if we're going to talk about surface area and volume for the cone, so we're going to talk about a cone, surface area of a cone. Okay, so one of the shapes in here is a circle, but there's only one circle in a cone, so it's going to be pi r squared plus, now this is not a rectangle because it comes to a point at the top. So there's not really a way to remember this. It's just pi times r times your slant height. So pi times your radius times s, which stands for the slanted side. Now, volume for a cone. Okay, so remember, volume of any object is the area of the base times the height. Well, the base is a circle, so that's pi r squared times the height. But that is the volume of a cylinder, not a cone. I said this in the last video, and if you're not watching the videos, you're missing out. Tell your friends. If you've got slanted sides, when you're doing volume, you divide by 3. When you're doing area, you divide by 2. Think about a triangle. You do base times height, but then you divide it by 2. When you're doing area, you divide by 2 for walls that are slanted. When you are doing volume, you divide by 3 for walls that are slanted. So we now have the formula for the area and the volume of a cone. So that brings us to example 3 and example 4. Example 3 gives us a cone, not a triangle, and it tells us that the radius is 6 and the slant height is 10, and they want to know the surface area to the nearest tenth. So I'm going to 1 decimal place. So I'm going to do surface area is pi times r squared, so 6 squared, plus pi times the radius times the slant height. So this is really 36 pi plus 60 pi. And I would just put that in my calculator, 36 pi plus 60 pi, and it works out to be 301.4. And again, this would be centimeters squared. We're finding surface area here. Example number 4, last example. example number 4 says find the volume of this cone, and it actually puts it upside down. That's technically an upside down cone right there. But they tell you that the radius is 0.8, and they tell you that the height is 3.5. That is the height. So if we want to find the volume is pi times r squared times 3.5, all divided by 3. So again, I would just put that in my calculator. And when I put it in my calculator, and they say they want us to round it to the nearest tenth again, it works out to be 2.3 centimeters cubed. So that's it. That's the homework. That's that section. I will post the homework in Google Classroom. We are going to do a test on Friday. Okay, I've written it in my book. So unless you have a bunch of other things, and if you do, again, you can just let me know that. But we're going to do a test on Friday. So at 8:30 in the morning, it will be posted. You will do it and give it to me by 9:40. That gives you, well, by 9:50 really, that's when your next class technically would start. So if you have to get into a video call or something with that, that gives you time to do that. So Math 9, 8:30, Friday, you're going to do a test. I'm going to post work for you to try today. Either tomorrow or the next day, I will post just a quick review video for those who want a refresher on what will be in it. I'm not going to sit and do a million examples, but I will go over what we have done in this chapter for you. All right, so that's it. Have a good Tuesday.